Hello and welcome to Chapter 5, Section 3. Today we're going to talk about side angle side triangle congruence. If I gave you two popsicle sticks of a specific length and I gave you the angle measurement between them, how many different triangles could you make? I give you this popsicle stick and I give you a very specific angle and I give you this popsicle stick. How many triangles can you make? There is only one. You can only connect them that way. There's no other way you can make a triangle. So this is side, angle, side congruence. Here we have the directions: construct triangle DEF by copying angle A, line AB, and line AC. So I want to copy line B.
So that's E.
So that is an exact copy of ABC. So I'd like you to try Explore 2, Section A, where it asks you to do the same thing. Give it a try, come back when you're done. Next, we're going to look at deciding whether triangles are congruent using the side angle side theorem. So here I have two triangles, ABC and DEF, and I know that line AB and line ED are both 20. I know that line AC and line DF are both 19. And the question is, now this is the angle between these two lines, that's 43, and this is the angle that's between these two lines, and that's 45. Are these two triangles congruent? No, they're not. Because of side angle side theorem, this line is going to be longer than 15 because it's open wider. So therefore, they're not congruent. So try B and come back when you're done. Here we have JKL and MNP, and we know that both of these lines are 74, and both of these lines are 46, and the angle in between them both is 37. Therefore, based on side angle side theorem, these two are congruent. Try your turn number 3. Come back when you're done. Here we know that line DE and line GH are the same. We know that JG and DF are the same. And we know that the angle G and angle D are congruent. Therefore, we have side angle side theorem, which makes both the triangles congruent. Let's try using SAS in proving triangles are congruent. So here we have that line BD is a perpendicular bisector of line AC. And the question is, are these two triangles congruent? Well, we know that angle BDC is 90 degrees. That's given. We also know that this one is 90 degrees just because of the nature of perpendicular bisectors. ADB plus CDB is 180 because that's the definition of linear angles. So we also know that this angle is 90 degrees because they're supplementary. So there's two different ways to prove that that's 90. We know that this line equals that line because that's the definition of a bisector. So because we also know that we don't have the reflexive one. Oh, I've skipped a step. I skipped the step that line BD is congruent to line BD because of the reflexive property, which says that something is congruent to itself. So now we've proven, because of side angle side theorem, that ABD is congruent to CDB. Try B. Pause. Come back when you're done. With B, we know that CD bisects AE, which means these two are congruent. We also know that AE, oops, I did that backwards. AE bisects C. We know that these two are congruent. I did them backwards. We know that these two are congruent because that's a definition of a bisector, and these two are congruent because that's a definition of a bisector. We know that this angle is congruent to this angle because of vertical angles, which gives us SAS. Try your turn number 4 and come back when you're done. We know that line AB is congruent to line AD. That's given. We know that angle 1 equals angle 2. That's given. We know that line AC is congruent to line AC because of the reflexive properties. It's congruent to itself. Therefore, we have SAS. Try elaborate numbers 5, 6, and 7. Number 5. If it's not the included angle, you could make different size triangles. Number 6, if you reflect it across the center line, so point Q matches point U. And number 7, a second side and the angle between them is what you need. And our homework tonight is numbers 1 through 13. Let me know if you have any questions, and I will see you next time.